Okay, n is an integer. What is an integer? Well, an integer is a whole number. Okay, you knew that, but we'll put it down anyway. So n is a whole number. And we're asked to prove algebraically. Now that often worries people, but actually you usually just follow your nose, so don't worry about it. Prove algebraically that the sum of that thing and that thing is always a square number. Let's not worry too much about the square number bit at the moment. Let's just worry about the sum bit to start with. That just means add them. Okay, so the sum is what you get when you add them. So let's try adding these things together and seeing what happens. So the sum that we're interested in is a half n times n plus 1 plus a half n plus 1 times n plus 2. Okay, not too painful so far. Let's try multiplying these things out because I can't think of anything else to do. The first bracket is just n times a bracket, so that's pretty easy. So I've got a half. Well, n times n is n squared, and a half n times 1 is a half n. So that was the first bracket. Now what about the second one? Well, I've got a half of two brackets multiplied together, and I like to use, for two brackets multiplied together, something called FOIL. Now you may use other things, but here's how FOIL works. FOIL is first, so that's the first one in each bracket multiplied together. Outer, so that's the outside pair of terms, the inner pair of terms, and then the last pair of terms, like that. Okay, so let's just do that one step at a time. First pair the first term in each bracket is n times n, which is n squared. The outer pair was n times 2, which is 2n. The inner pair is 1 times n, so that's just n. And the last one in each bracket is 1 and 2. 1 times 2 is 2. And so we've done that. Right, let's just sort this out a little bit, simplify it if we can. So I've still got the half n squared, I've still got the half n. And now let's take this half outside this bracket and multiply everything inside the bracket by that. So I've got a half times n squared, which is, strangely, a half n squared. Now the next bit's a little bit more complicated because actually I'm also going to lump those two things together and do a half times that. So 2n plus n is 3n, and a half of that is, well, I'm going to call it 3 over 2n. You could call it 1.5n if you want to, or 1.5n. And then I do a half times the 2 at the end. And a half times 2, that's nice and easy. That's 1. And now, what about putting these things together? Well, I've got a half n squared and a half n squared. And a half n squared plus a half n squared is a whole n squared. And then I've got half an n and 1.5 n's, or 3 over 2 n's. And a half and 1.5 makes 2. So that gives me 2n, and then I've just got the plus 1 on the end. Now, is that always a square number? Well, yes it is, because if you think about n plus 1 all squared, okay, and multiply that out, you get, doing the FOIL thing again, n squared plus n plus n. So there we go, doing this one reasonably quickly. And then at the end, plus 1, which is n squared plus 2n plus 1. Now that's n plus 1 times n plus 1, but don't forget that that is n plus 1 squared. So I can write this as n plus 1 squared, which is always a square number. Okay, and we'll just write that down to complete our proof. And so without doing anything terribly painful, we've done one of these prove algebraically questions. Well done us.